Greetings, people of the interwebs. Today I'm going to talk about some of the different filters that you can use on your sounds. The more you create sounds, the more you build up a familiarity with your tools. In doing so, you start to make little mental notes of what certain effects do, and that way when you hear them in tracks, you can identify what is actually being used to get certain results. And it all comes down to practice, really. The more you play with all the different plugins and tools at your disposal, you then develop a strong vocabulary of different techniques that you can use to shape and create the sounds you're after. And with no more ado, I'm going to get right into the video. Okay, so first of all, I'm going to grab myself a trusty serum here. I'm just going to stick with a saw wave for now because it's a full spectrum sound, so whatever filtering we do is going to be more obvious. As you've probably seen in the last videos, the low pass is just a simple filter that removes all of the frequencies above a certain point. This filter has a few different steepness options. So you can go with 18 or 24, which is nice and sharp. And the steeper the curve, the greater the disturbance of phase to the signal is. If you click on the filter, it'll show you the spectrum. If you click it again, it shows the way that the phases are being displaced, because the way that a filter works, it's got a curve that rotates the phase. As that curve reaches the bottom part here, that becomes where the signal is fully flipped, and thus everything above the point where the signal is flipped by 180 is cut away by phase cancellation. So EQ uses phase cancellation to remove frequencies at certain points. The next filter is a high pass filter. This cuts away all of the low frequencies. And the resonance control is how sharp the boost in frequencies at the point of cutting. Next up, we have a band pass, and a band pass just constrains the area of frequencies to a nice little central point. And then we've got a peak filter, which is just a little boost. And we also have a notch, which is just a little cut. Which is really useful for making these liquidated type of sounds. Next up, we have this multi-section, which basically combines some of these simple filters into a combination of filters that are processing it in parallel. So here we have a low band filter, which is a band pass, but it also has this low control. We got a high notch here, which is a high pass, but it also has a little notch frequency in it. And with a lot of these multi-filters, it's really satisfying when the frequencies travel in the opposite direction. That's resonance. And yeah, you've got a cool effect already. This is exasperated when you add a bit of distortion on as well, because the resonances are feeding into that distortion. So that is the premise of a lot of sounds, is just to take advantage of the resonances on the filters and use them in designing your sounds. For example, if we've got this high pass here, then you can see that that resonance is controlling at what point we have a burst of energy going into that distortion. And this can be really cool in combination with a sub bass, so then we have that low end going into the distortion as well as our selected boosted frequency. So there you have that. Next up, I want to talk about flanges. These types of filters are a series of boosts and cuts in the spectrum. if I exaggerate this resonance here, you can hear that you get this very metallic characteristics from it. And then we've got the comb minus, which is the opposite version of that. And the resonance is like the feedback of that effect. If we have a flanger, as I mentioned in the last video about stereo, a flanger is a time-based delay effect. And as it gets delayed, it's causing this comb filtering in the spectrum. The way that a phaser differs from this is that it's phase shifting the original signal and then blending the phase shifted signal back with the original, rather than just a simple time delay. With a time delay, you get harmonically spaced notches, and a phaser, you get these inharmonic spacings of the notches. Such a satisfying effect. Next up, I want to talk about the formant filters. These are really useful if you want something to have a bit more of a vocally property. Next up, I want to show the band reject filter, which is kind of like just a notch, but it's a lot more extreme. And the resonance control controls these bumps on either side of them. It can be really useful for making gritty bass sounds. If I bring up the volume for this, change the voices. If I put the distortion on as well. Width control here. So as you can hear, lots of really interesting tones that you can get out of that. The other thing that I want to just touch on real quick is the notches in a spectrum cause that kind of gooey, phasey effect. But if you go with the peak filter, which is just two little boosts here, I find that boosts in the spectrum can get you that more vocally texture. So if you attach opposite modulations onto these two peaks, then you get this vocally type of quality to it. Really useful for if you want to make something sound like it's more talking or vocally, you know, it's got that like throaty texture. So yeah, boosts in the spectrum, vocally type stuff, and cuts give you that gooey, phasey sound. With all that out of the way, I'm going to go ahead and make a sound using these filters. Let's just go with some kind of neuro-y style bass, because why not? I'll leave this first one as a saw wave. To make things interesting, I'll show you another way that you can generate waveforms through just drawing them in manually. Let's say if you want a chord shape like this. Hold Alt, click on the LFO tab, and then hover over the oscillator and just let go of it. And then you've got yourself that waveform. So if I use this as maybe an FM modulator, and then maybe give this on some sync, which is essentially pitching it up. It's just folding the waveform on itself, but it's got all of these in-between parts where the tone changes because the waveform in itself is not its full thing. Maybe if I put this an octave up. Maybe 7 semitones. Before I mess with any more things, I'm going to stick on a bandpass filter, which is going to just constrain those frequencies into a small segment if I put both the oscillators into it. And then what we'll do is get ourselves some nice shape modulation, because it's the movement filter that will really make it come alive. It doesn't sound like much at the moment, but if I add in a sub bass and then distort those together, start messing with some of these other parameters now. What I'm going to do is I'm going to render the sync feature on my oscillator B with this setting here, render osc B warp. And that way we have that sync feature on the wavetable position knob, and then we can repurpose what was originally on the sync and maybe quantize or something. Let's get some noise in the filter as well. Sounds pretty naughty. Maybe put the movement on the distortion as well. And get a compressor out, which will take down the loud parts, and therefore as you bring up the level of the overall signal, the dynamic range is reduced and you have a fuller sound over time. And the multiband compression just does that on a per band basis, but also simultaneously does upwards compression, which is getting the quiet parts and increasing them in volume. And the way that that works is that if I play this, all the things that are going over into these green bands here are being compressed downwards, and everything that's quieter, for example this high end here, is being brought up because it's in this lower band area here, and you can control the amount of frequencies in each band as well as the overall settings. And if I put the compressed signal before the distortion, then you're feeding the distortion a more consistent signal. In this case, I prefer the sound of it after, because the distortion is actually changing the dynamics of the sound anyway. It just doesn't use these attack and release settings. The attack is just how long it takes before the volume is turned down once it crosses the desired threshold. And the release is how quickly it returns to normal volume after it has been compressed. So let's get some effects on this to bring it to life. Bring the mix down for that. Just playing with the shape, seeing if I can't find anything interesting. And as you can see, because there is resonance on this bandpass, the frequency that I decide to go to is picking out certain harmonics for the distortion to emphasize. So we got very targeted distortion. And then what I'll do is I'll just get a quick modulation on the master tuning as well, which will give it a nice punch at the start. Grab LFO5 and put that on the global master tuning. Set that to an amount that we like. Let's go just an octave for now, which is 12, and then you have to type in ST if you want semitones, because if you just type in 12, it will use it as a value from 1 to 100. Rather than the actual semitones amount, and just switch that to unipolar so it's one way. Ooh yeah, very nice. Next up I'm going to add a phaser, and I'm going to put that before the distortion as well. With a phaser I might turn the rate and the depth down and then maybe have it follow that movement. Cool, and then if I turn the mix down, we only need a little bit of it. Flanger for a bit more movement as well. I might put that afterwards, we'll see. Bring the rate down. So you can hear that from the delay that we're getting from this depth knob, we're getting that comb filtering effect with boosts and cuts in the spectrum. I like it after the other effects because it's just sounding a lot cleaner that way. And then maybe let's go with a band reject filter at the end as well. Let's go band reject, get the width controls on the movement as well as the cutoff. And then what we can do for a bit more movement as well is maybe go with another notch filter before the distortion and just control the frequency for that as well. And then maybe either a boost. I might go with a cut also for this one. Put that on the mod. So it's a bit cleaner, a bit nicer with this. Pretty satisfying. That pretty much does it for this sound. Then you can go back to the oscillator tab, play with some of the settings and get vastly different results. Let's say if you get the bandpass filter and just move that around, change the shape maybe. And now we've got something that sounds a bit more growly. Maybe if we change this. And then if we get these things to move as well on the wavetable. Maybe change this to just a bend. There's so many things that you can do by experimenting with the different filters and just having fun with it, just playing with it. So yeah, just try stuff basically, and that's the key to making experimental sounds. So I hope you enjoyed this video. or got something out of it. And if you want to support the channel, you know what to do. And I'll see you on the next video.